good day to everyone. So my name is Muhammad Faizal, and I'm going to present to all of you about our project design regarding the FFB. So we are from a group one, and the first thing I'm going to do is to present my group members, which is we have Muhammad Imran Ramli, the group leader of this project, and second is me, Muhammad Anafi bin Muhammad Faizal. Next we have Muhammad Azfar Shahami bin Muhammad Azlan. Then we have Nazrin bin Ibrahim, and the last one is Muhammad Azad Ifan bin Muhammad Afandi. So, alright. So for the first one, we have the chapter one is about the introduction of our project. The problem background is regarding the Sign W plantation Berhad, which is the one of the biggest producer of the palm oil. So the next one we have the problem statements. Problem statements is the problem that we already interviewed to the company, which is Sam Darby. They stated that they have a problem regarding the harvesting of the palm oil. So next one is objective. So we have already listed two objectives in this project design, which is to design a mechanical harvesting machine for FFB, which can reach 20 to 35 feet tall palm oil tree, and then to develop a performance analysis of the harvesting machine for FFB. And then we have the limitation or scope of our project, which is to design and development of harvesting machine for FFB. And second one is the harvesting machine must comply with three mechanisms, which is elongation, cutting, and collecting. Third one is discuss on the conceptual design, which fulfill the needs statement, and selected design will go through screening and scoring process. And the last one is to deploy a prototype simulation using suitable computer-aided design CAD software. So we have so let's talk about the overview of the overall design report. So we have chapter one, which is about the introduction. We have problem statement and overall, and then chapter two we have the literature review, and also come up with the PDS or product design specification. And next is chapter three. We have the concept generation and selection, and the last part we have the detailed embodiment for the selected design. So next. Right, so I pass this presentation to Azhar.
All right. I would like to continue the PDS or product design specification. First of all, there are five member of our group. Each members um, each members provide one of the product that can be used to redo analysis, and from the product um, we can improve to produce our own product. So product from Aiman Ramli is a mechanical harvesting machine. You can see from the pictures here. This is 100% mechanical and using machine. And the next one is from myself. My product name is Chantas, and this is the specification of the product. Next one is from Hanafi Faizal. The product name is Palm Pro, and this is the pictures of the product and also the specification. And the next one is from Nazrin. The product name is Chisel. So basically, this product um, is quite basic because it consists of pole and chisel. And then this is the specification of the products. And the last one is product from Asfar, which is Chantas also. The difference between myself and Asfar is the name is the same, but the power supplies is different because from my product I'm using motor power supply, but for Asfar is using engine as a power supply for the mechanical part here or cutting head. So this is the specification of the products from Asfar. And then we move to the PDS itself. So the need statement for our product to the need statement before we uh, proceed to design our own product is here. The equipment is like to handle, does not require complicated step or process to perform, and then there are many more that need statement that we list here. And then after listing all the need statement, then we move on to the next need matrix. The need matrix will consist of metrics, needs, importance, and the unit. For the total mass, the importance is 4 and the unit is kilogram. Product lifetime or endurance limits, the importance is 4 and units in year. Cutting time of FFB, the importance is 4 and the unit is minutes. And safety features, the importance is 3, the unit is meets the ISO. Standard operating procedure SOP, the importance is 4 and the unit is meets ISO. And then the metrics for volume of the container for FFP storage, the importance is 3 and the unit is meter cubic. Material strength is the importance is 4 and the unit is in Pascal. And last one is length of the harvesting equipment of the machine. The importance is 4 and the unit is in meter. Then after we came out with the need matrix, we move on to the benchmarking. Benchmarking consists of metrics, the importance. Just copy here and paste it here, but we add on the products or that we um, or each of the member bring. So this is from Aiman Rambis. This is from me. This is from Hanafi. This is from Nazrin and Asfar. And you can see here we use numbering here, and we sort out and the importance. We sort out the only important things, so so that we can come up with the final design of the product. And then this is the last part of product design specification. I think I will like to proceed and I would like to pass this presentation to Nazrin. I'm sorry, to Aiman Ramli about concept generation.
Okay, move on to our concept generation and selection. So during this process, the concepts generated earlier in the design process are being evaluated, selected, and synthesized into a final solution for further development in order to address the design goal. So this concept generation is an important process in order for us to come out with the best final design selection. So next. So here, our general statement is to use less labor energy in harvesting FFB by improving the conventional design of FFB harvesting equipment. So we've come out with our input, which is energy, and our output is FFB. So the function decomposition that we choose is first lengthen equipment, then cutting FFB and collecting FFB. So based from these three function decomposition, we have brainstormed together and we've come out with 10 options listed under this kind of function decomposition. For example, as what you guys can see inside the table in figure 3.2. So every single function decomposition was selected by our group member. Okay, next. So here is the morphological chart. So based on the function decomposition, we've come out with this option. And next. And after that, every team members will come out with each sketching that from the function decomposition selected. Okay, next. So here are the sketches from our group members. And from these sketches, so we've undergone the concept screening process, which is the first concept screening process is for eliminate ideas that are not worth pursuing. So from this concept screening process, uh, we've come out with the decision. So if you can see the next page, the decision is we will continue with this four design, and this four design will Iman one, Azhad one, then Hanafi one, and lastly Asfar two. Okay. Then from this concept selection, we'll go to the concept scoring. So from this concept scoring, so we've already finalized that our best design will be uh, Iman one, as it is ranking number one, and this design will be further developed. So that's all from my side.
Thank you, Ayman, for the detailed explanation of concept generation. Next, I'm going to explain about the design efficiency for this product. Can you scroll down a bit? So for design efficiency is a rating which can be used to decide the effectiveness of the design, and it can also be used as a benchmark for future enhancement. So for this process, firstly, we are going to decide the A component and B components for the product, and we decided to follow the guide to decide the component. Next, we are going to total up the A components and the total components, and by using the formula which is provided by our lecturer, we are able to calculate the design efficiency of the product. So finally, we have achieved the design efficiency, which is at 68.83% for the product. So next is the costing of the product. For this part, we actually analyze mainly about the cost of the product. First of all is the material costing. For this material costing, we have divided into two, which is aluminum alloy and carbon steel. Since these two materials are the main materials which is required in the production of the product. So what is needed is the weight and the volume of the material needed, and with the information we are able to identify the price of the material for the product, and including and standard component is also included in the material costing, such as the battery, the connectors, and the bearing, and which total up to 998.5 ringgit. So by adding with the material costing and the standard component, we have achieved the total cost of the product at 1,551 ringgit and 42 cents. And that is all for the costing.
Moving on to failure mode effect analysis, or FMEA. FMEA is a method for finding all possible flaws in a design or assembly process. Scroll down to FMEA table, please. So for FMEA, our group had covered all parts of the components such as motor, grapple, and the pole. Most of the possible failures that could happen on the product had been brainstormed and were added into the FMEA. Based on this, there are three different colors that defines three different reasons. If the color is red, we should eliminate or reduce the level of the failure. If the color is yellow, we should eliminate the risk or reduce its level. Lastly, if the color is green, the risk is acceptable. As can be seen here on the FMEA table, there is only one component has red level of risk, which is the grapple. Therefore, we had decided to perform engineering analysis to that component. And that is all from me.
All right, so we move on to the engineering analysis. So this is the manual engineering analysis of the pole using manual calculation. You can see the figure above shows that two-dimensional analysis of the grapple pole. It is assumed that the FFB here will create downwards force at the tip of the pole, which is around 196.2 Newton, because normally the standard weight of the FFB around 20 kilograms. So we times with gravitational force, so we get the value of 196.2 Newton. So after we determine the all the variables and we do a free body diagram here, and then after do the calculations we obtain the values, uh, obtain the reaction force on the x-axis, which is at the x-axis there are no force in the direction of x, while at the y-axis there is a value of 335.84 Newton. Then we move on to the next calculation, which is the maximum horizontal shear stress. Using this formula, we obtain the value of 150.09 kilopascal. Next is the maximum tension bending stress. Using this formula, we obtain the value of around 79.97 megapascal. So the value obtained here is quite significant, and it is also value to we as a benchmark to so that um, our re, in a real situation, this value will not exceed this value of calculation. The value of in real situation, we must avoid to exceed this value of from we obtain from the calculation. So the grapple pole will not break or fail. This is from the manual calculation, and then next we use simulation or automatic calculation using CFD software. Here we are using a CFD software. Here we are using SolidWorks. This is the analysis of the grapple, and from the picture depicts here, this is the right side of the grapple. These grapples used to hold the FFB during after the cutting process. So you can see that the blue colors here indicates that the value or the value is quite safe, and we just apply back the force of FFB, which is 196.2 Newton downward, and the material used for the grapple is a gray cast iron material. So after doing some simulation, we can come out that this analysis was done by using the CAD software, and the distribution of von Mises stress on the grapple can be observed, and the stress value are used to find out if the material will yield or fracture. After running some analysis, we can say that the material will not fail during performing its function, because there is no excess or high value of stress here from the picture here. Then this is all from me. We move on to the next presentation.
Alright, so now I'm going to continue about the CAD modeling. So can you please open the CAD modeling? Alright, so this is our CAD modeling by using the software of SolidWorks. So the reason of we using the CAD modeling is to give a side view to our panel, how our product going to be in in the prototypes. So can you just please move to the next image. Alright, so this is a full detail embodiment which we use in type of photographic view to give a side view for the planner to see how our designs is going to be if we're going to develop in future. So I think that's all for my presentation.